everyone! Welcome to our magical factory, where CNC technology makes wonders happen. Let's dive deeper into CNC technology with the help of our characters, Robot Bob and Craftsman Fred. First, let's introduce Robot Bob, who is the driving force behind using CNC technology. Bob, what makes CNC technology so special?
Hey folks! CNC stands for Computer Numerical Control, which means computerized control using numbers. It allows us to automate the manufacturing process using specialized computer software.
Oh, so that's why CNC machines are so advanced and precise.
Exactly, Fred. Let's see how CNC technology works in producing complex and flawless components. When we provide a design to the CNC machine, such as a blueprint, the machine uses computer programming to control the movements of its cutting tools. This enables the machine to cut, drill, and shape the workpiece according to the precise design.
That's right, folks. CNC machines can work in 3 different axes, such as the X, Y, and Z axes. This means the machine can move forward-backward, X, left-right, Y, and up-down, Z. These movements are controlled with great precision by the computer.
CNC technology offers many advantages. With high speed, accurate precision, and the ability to create a wide range of products, CNC has revolutionized the manufacturing industry. CNC technology is used in various industries, including automotive, aerospace, and woodworking. From manufacturing automotive components to crafting custom furniture, CNC plays a vital role. For those interested in getting started with CNC technology, the first step is designing the product using design software. Then, a CNC program is created to instruct the machine. Finally, the machine is properly set up to initiate production. During the 1940s, precision manufacturing became a matter of utmost importance. Several obstacles often occur, such as jammed weapons which result in soldiers not being optimal on the battlefield. The war effort required accurate and consistent production of complex parts for weapons, aircraft, and other military equipment. John T. Parsons and Frank L. Stulin were 2 important figures in the history of CNC machines. They were pioneers who played a significant role in the development of CNC technology in the 1940s. John T. Parsons was an American engineer and inventor widely recognized as the father of CNC. He had a vision to improve the speed and precision in the production of aircraft components. In 1947, Parsons created the first numerical control, NC system, known as numerical control. This system combined hardware and software to automatically control the movement of cutting tools based on numerical instructions. Frank L. Stulin was an engineer and collaborator of Parsons who played a crucial role in the development and dissemination of CNC technology. He worked alongside Parsons to develop the first practical CNC milling machine, which was first used in 1949. This machine utilized numerical control to drive the cutting tools and achieve high precision in the production of aircraft components. The hard work and innovation of Parsons and Stulin paved the way for further advancements in CNC technology. Over time, CNC has evolved into more sophisticated and integrated systems, enabling highly efficient and precise manufacturing processes in various industries. And that concludes our journey into the fascinating world of CNC technology. We hope you enjoyed this video and gained a deeper appreciation for the impact of CNC machines in various industries. If you found this video informative and engaging, be sure to like and subscribe to our channel. Don't miss out on our future content where we delve deeper into the world of technology and innovation. Thank you for joining us. Until next time, keep exploring, keep creating, and keep embracing the power of CNC.